Today we are diving into a pretty chilling ecological mystery. It's about a silent plague that is taking down one of North America's most iconic, most incredible animals. But, this isn't some simple story of predators and prey. No, what's happening is a lot stranger, and honestly, much more terrifying.
We're talking about the moose. This is a creature so massive, it looks almost prehistoric, right? It's a true symbol of the untamed wild. But for years now, this king of the forest has been falling. And for the longest time, nobody knew why. The culprit? Well, it's not what you think.
And just look at the sheer scale of this collapse. It is staggering. This isn't some slow, gradual decline. It's a complete free fall. In northwestern Minnesota, the population just plummeted from over 4,000 moose to fewer than 100 in just 3 decades. This wasn't just a local problem. This was a massive warning sign flashing bright red.
So, what were people actually seeing out there, on the ground? Well, the evidence was deeply unsettling. Hikers and game wardens, they started coming across these scenes in the woods that just made no sense in the natural world. And this is where it gets really weird. These massive animals, they were just dead. There were no signs of a struggle, no claw marks, no bite marks from wolves or bears. Get this, even scavengers wouldn't touch the bodies. It was as if they were just switched off. With the usual suspects, the big predators, ruled out, the mystery just got deeper and deeper. And then there were the live ones. People started seeing these strange, pale apparitions moving through the woods. They even got a nickname, ghost moose. Their dark, thick fur was being rubbed away, leaving them with this ghostly, washed-out appearance. And that bizarre look? Well, that was one of the first major clues that whatever was happening was slow, it was agonizing, and it was coming from within.
Okay, so with a crisis this big and this mysterious, scientists knew they had to get some hard data, and fast. A team of biologists up in Maine launched this massive operation to get to the bottom of the silent slaughter.
And their plan was this huge, expensive, and honestly pretty intense effort. They used helicopters to capture dozens of newborn moose calves, and they fitted them with these high-tech GPS collars. Every ping from a collar was a sign of life. The idea was simple, but brilliant. Track the calves through their first critical winter, and the second a signal went flat, meaning the animal hadn't moved, they'd rush to the site to figure out what happened. The results from that very first winter, they were absolutely devastating. 86%. Out of 70 calves they collared, 60 of them died before spring even arrived. Just think about that for a second. Losing almost 9 out of every 10 young animals in a single season, that is an ecological catastrophe. The team knew, right then, they were dealing with a killer of terrifying efficiency. So when the biologists performed necropsies on all those dead calves, they didn't find evidence of wolves or some new exotic virus. The killer wasn't big. It wasn't fearsome. It was microscopic, and it had been hiding in plain sight all along. The culprit was the winter tick. Now, this isn't the deer tick you've heard about that spreads Lyme disease. No, the winter tick is a completely different beast. It has this unique one-host strategy. Thousands of them latch onto a single moose in the fall, and they stay there, feeding on its blood all winter long. To really wrap your head around the scale of this attack, consider this number, 90,000. That's the record number of winter ticks found on a single adult moose. They called her Moose 59. Can you even imagine an animal trying to survive while being fed on by an army of 90,000 tiny vampires? It's horrifying. So how does a tiny little tick kill a 1,000-pound animal? Well, it's the slow, brutal 3-part breakdown. First, you have massive blood loss, which basically starves the moose from the inside out. Its body burns every last calorie it has just trying to make new blood. Second, the constant, maddening itching drives the moose to rub its fur off, and it loses its vital winter insulation. And third, that combination just leads to this slow, inevitable, grinding decline. But here's the big twist in this story. The winter tick is a native species. It's been in these forests for thousands of years. So why is it suddenly a weapon of mass destruction? Well, the answer is that we, humans, inadvertently created the perfect storm for it to thrive. So the first ingredient in this perfect storm is climate change. See, historically, an early frost in October would kill off the tick larvae, ending their season. But now, that first killer frost might not arrive until late November or even December. This longer, milder autumn is basically a gift to the ticks, giving them weeks, sometimes a month, more time to find a moose host. And that leads to way, way higher infestations. The second factor is something scientists call density dependence. Basically, decades of heavy logging created a perfect moose buffet, just miles and miles of young shrubs and plants for them to eat. So the moose population exploded. But packing so many animals into one area also created a perfect breeding ground for parasites, right? More hosts means more ticks, and that cycle just spirals completely out of control.
But the story doesn't even end there. As if the winter tick wasn't bad enough, it turns out that moose in the southern part of their range are fighting a completely different and just as insidious parasite. It's a war on two fronts.
So up north, the main threat is the winter tick, killing by blood loss. But down south, the enemy is the brainworm. It's carried by white-tailed deer, and instead of attacking the blood, it attacks the moose's central nervous system, causing awful neurological damage.
And its life cycle is just bizarre. The parasite lives in deer, totally harmlessly, and its larvae get passed into snails and slugs. Then a moose comes along, browsing on plants, and accidentally eats an infected snail. Now in a deer, this is no big deal. But inside a moose, the worm literally gets lost. It burrows into the brain and the spinal cord, causing confusion, paralysis, and a really slow, agonizing death.
So, when you're faced with this two-front war, what on earth can be done? This is where the story shifts from being a biological mystery to being a really profound warning about conservation in the 21st century. Biologists are now facing a grim calculus.
And this leads to the gut-wrenching question at the heart of it all. To save the moose as a species, do we actually have to kill more of them? I know, it sounds completely backward, totally counterintuitive, but the science behind it is shockingly solid.
See, since that high moose density is what's fueling the tick explosion, the only real way to break the cycle is to reduce the number of hosts. In other words, you have to starve the ticks. It's a strategy of quality over quantity. You're aiming for a smaller but much healthier herd. And in the experimental zones where they've actually tried this, it's working.
And we have to ask, why go through all this trouble? Well, it's because the moose isn't just another animal in the forest. It's an economic engine for small, rural towns. It's a sacred cultural icon for indigenous peoples. And it's a key source of funding for conservation programs through hunting permits. Losing the moose would leave a hole in our world that just can't be filled.
When you get right down to it, the moose's plight is like the canary in the coal mine for all of us. It's this profound, chilling warning that shows how even the slightest shift in climate can unlock a biological monster. Climate change doesn't always create brand new threats. What's terrifying is how good it is at weaponizing the ones that are already here.
And that really leaves us with a final, pretty sobering thought. The moose is one of the largest, most powerful animals in the entire forest, and it's being brought to its knees by a parasite that's smaller than your fingernail, all amplified by just a few degrees of warming. If the king of the woods can fall this easily, it really makes you wonder, what or who is next?